So in the previous lesson, we talked about using a factor method to kick things off, which will return a completable future to an optional URL. And now we're going to talk about what we do with that result. And of course, what we're going to do is if we've got a non-empty optional in our completable future, we're going to go ahead and download the image asynchronously. So let's take a look and just reorient ourselves where we are in the pipeline of operations here from the stream. So remember, map, the previous call to map for check URL cached async with that method reference passed in, that will go ahead and basically get a stream of completable futures to optional URLs. And you might ask, why don't we just filter these things out? Why do we need to go to all this trouble to keep them percolating around as optionals? And the reason is because filter doesn't work in any sensible way with completable future. Filter only works on predicates, but a completable future is not a predicate. So you have to actually get the result before you can filter it. So we can't use filter here. We could use filter in the parallel streams version because all the calls were synchronous and we knew that we had the actual object by the time we did filter on it. But here in the asynchronous world, we don't have that luxury. So we have to defer the things till later. And so we're going to see how this percolates down through the call chain. So map, as you can see here, calls the behavior download image async, and that asynchronously downloads an image and stores it in memory. And as you'll see, the later behaviors will simply ignore empty optional images. Why would you have an empty optional image? Because you had an empty optional URL. So if the URL was already there, we're not going to pay attention to it. We're going to ignore it. So of course, that's going to get percolated down to this call to download image async. And if we had an empty URL, we're just going to ignore it, which means we have an empty image. So the empty image will then percolate down. And you'll see how we get rid of these empty optionals later. So what comes back from map here is a stream of completable futures to optional images, which have a value if the image is in the process of being downloaded asynchronously, or are empty if the image was already cached. So let's take a look and see how this particular thing gets done. This is really, really cool. So if you check this out, you can see that download image async takes a completable future to an optional URL. And I call that URL future just to make it concise. And what we're going to do here is we're going to say URL future when that completes. In other words, when we know that a URL either was cached or not cached. If we already know, when we know that, when that asynchronous operation that was invoked by the supply async factor method is done, then go ahead and call apply async. And this goes ahead and registers this action that will be executed when the future completes. So this will not be called right away. It'll only be called when URL future completes, at which point this action will be called. And of course, it'll be called in the common fork join pool because that's the executor that we're passing in here. Now, here's where things get really interesting. Remember, we've got optionals here. So it may be the case we don't have to download anything because if it's an empty URL optional, empty optional to a URL, then we're just going to ignore it. Well, how do we make this work? Well, it's very simple. The optional, this thing here, URL optional, this is actually an optional object. If you have an optional object and you call its map operation with an action, that action is only run if the optional has a value. But if the optional is empty, of course, it's just ignored. So you can see what we do here is we're going to pass in the blocking download behavior here, but this will only get called if the URL optional had a value, and it won't have a value if we'd already cached the image. So this is how we're percolating the optionals down through the call chain. So they only do something useful in the case where we had something that we needed to process. If map is not called, then we'll get back an empty optional to an image, which is exactly what we want. Notice how we're using then apply async, and that arranges to run blocking download if it needs to be run because it's being used on a non-empty optional in a background thread in the common fork join pool. So this is a really clean thing. And your assignment number 3 will also do something along these lines with then apply async. And you can see here again, we use the common fork join pool. That's what getExecutor returns. And under the hood, it uses a managed blocker. So we talked about managed blockers before. If you look at the code for blocking download, you'll see it uses the managed blocker. Here's the blocking download method call. you can see it takes a URL and returns an image. So it transforms a URL into an image by downloading the image via its URL. And we use our clever little wrapper class called blocking task and its call in manage block static helper method in order to give it a supplier lambda. And this will then use the manage blocker interface, which will auto expand the common fork join pool to handle the case of the blocking image download. And this is the actual call. You can see here that download image, which will run in the context of the managed blocker, just goes ahead and downloads the content from the URL and converts it into an image. And that's nestled deep in the bowels of helper classes in this design. So just a useful thing to know how to do, download an image from a URL and then convert it into an image. So what comes back here is a completable future to an optional image, where the optional image will have a value present if it's in the process of downloading a URL from a server, and it'll have an empty value. It'll be empty if the URL optional was empty. Okay, so that's the end of the first part of applying completion stage methods. Here we're basically focusing on then apply async. That was the primary completion stage method that we're showing off here. And we'll see some other variants in part 2 of this lesson.